our next fireside chat, we're talking about managing the Resilience+Renewable imperative. And joining me here is Michael Oshetski, CEO of Micatu, and Dwayne Stradford, Managing Director of ENRA Strategic Initiative at AAP.
Thanks for having us. It's exciting to be here.
Thank you for joining me.
Yeah.
Yep. Thank you. Appreciate it.
Thank you. So, Michael, I want to start with you first. It seems like there's a perception that the intermittency of renewable energy is a challenge to resiliency, especially here in Texas, when a lot of people are still pointing to the failure of renewables as a reason for the widespread power outage during last year's winter storm. What would it take for us to have a grid that is fueled by renewables that is still reliable and resilient at the same time?
You know, that's a great question. I look at it perspective of, we have to evolve as we put more renewable energies into the power grid. And one of the things we have to understand is climate change is real, and incredible events happen that previously, we didn't see before. Snow and freezing in Texas, right? So it's a learning process, but I think as we deploy more renewable energy, we have more penetration, we definitely have more reliability. It goes back to the systems of numbers of having more reliable energy requires we have to have a deployment that's bigger. So I also see it as intelligence and having the ability to have more of a predictive response to power generation. I know, Dwayne, we had some good discussions about this too when we're talking outside here, is that it's a problem that has to be accounted for as you do these deployments.
Absolutely, but it's been solved other places because
Exactly.
when they talk about frozen assets here in Texas, Canada, they have wind, the Dakotas, Minnesota, what have you, they have wind. So they've solved the problem. So it's just a function of bringing that solution down here to Texas, deploy it to make sure that when the wind is blowing, you can rely on the wind being there for you, and then looking at storage as well to go along with. So I think it's just a matter of not reinventing the wheel, but also to reach out to other folks that have solved the problem, make sure that that solution is here so you don't have those problems moving forward. And after that Texas event, the lessons learned, I mean,
Absolutely.
Lord forbid if you ever repeat those mistakes again. So it's just a function of making sure not to repeat those mistakes.
Mm-hmm.
Yeah, I think you have to expect the unexpected. I think the walk-away lesson from that is climate change and extreme weather, right?
Right.
Yeah.
Right, absolutely. So one of the best ways to manage the grid is by getting accurate real-time data. What are the the current challenges to getting this data, and what solutions are utilities considering to give them the visibility that will help make them make informed decision about how best to manage the electric grid? Dwayne, you want to take this one first?
So with real-time data, some of the current challenges are because of past decisions made on the grid, because you got to remember a lot of the substations were manned. So the only thing that you had at a lot of these substations were telephone lines. We have the solution now with OPGW, where you have fiber that can connect a lot of these stations. You have that in the standard, but in the day, you still have some substations that have older RTUs that are out there. Mm-hmm. So you don't have a chance to capture all of the data that you really want to capture, especially with all the renewables that are being put onto the grid. So you want to capture like three-phase current, three-phase voltage, megawatt, MVA, megavar, and you want to make sure you get the statuses, all the switches and breakers and what have you. But I think also as you go through, you want to capture all the relay protection data as well, because again, you want to be able to know whether or not you have any misoperations out there on the grid. You want to know if you have any potential challenges with under voltage load shedding, what have you. So you just want to make sure that you get the proper communication networks out there so you can bring all that wealth of data in. And then, like previously we had talked about before, it used to be either it was a transmission project or a generation project or a distribution project. So a lot of times, a lot of the data, it was like Hunger Games. Like, no, you know what I'm saying? You'd be like, no, I just want all distribution.
It's an integrated effort, right?
Exactly, exactly. So it's a team effort.
Yeah.
So it should be everybody getting together and just saying, hey, look, this is all the information we want to get. We want to build at least 25, 50% capacity into the RTU so you can pull back everything that you know of and have room to grow for the stuff that you don't know that you need. kind of go from there.
Yeah, one of the things too we talked about too is having solutions that can both retrofit into existing systems and support future build-outs. Right. So you might have sensor systems that have analog outputs or digital or IEC 61850. So I think it's an approach where we have to be able to support existing deployed assets, but also integrate new future needs. And we had some fun discussion about what is that going to look like? Is more EVs? We got more renewable energy, and that's kind of a perspective too. I think we take when we look at this.
So, Michael, earlier this year, the Department of Energy launched the Building a Better Grid initiative to upgrade our aging infrastructure. What would you consider to be the top priorities for grid modernization, and how do you expect these priorities to be built into this initiative?
That's a really big question. There's a lot of different ways you can look at that, but the top things I see is resilience. Resilience is important, and I know, Dwayne, we talked about cybersecurity because that's one of the exciting parts, but I see resilience and really transformation of the grid from a really linear topology to more of a circular topology where, the prosumer is emerging that can generate energy and consume it. And I think the grid of the future is a combination of many aspects. Part of it too is, we had a great discussion about this too, is the education of not only customers, but users and the next generation of utility designers, engineers, deployment. It's a grid of the future, a lot of opportunities, but there's a lot of question marks, and I know. Yeah.
And then you got to have people that know how to do data analysis, data analytics, being able to crunch the numbers. Because we talked about being both electrical engineers. Yeah. So back in the day, it's like being an engineer that can do computer programming. You're like the unicorn in the industry, right? And now it's like we're data analytics, being able to handle the blocking and tackling, right? You want to be able to solve simple problems. You want to be able to use the data analytics so that you can put algorithms in place just to look for the basics and then build on top of that. Because a lot of times people just want to go from 0 to 60 and go to solving some elaborate problem. A lot of times we're not even handling the simple blocking and tackling of the grid. And if we can handle some of those basic principles and figure out where we have reactive vulnerabilities on the grid, where we run the risk of having a voltage collapse or anything like that, let's try to figure out some of those simple problems, put the algorithms in place, and then learn from them, and then we can grow on top of that.
Yeah, I think data is key. We talk about the grid of the future, but it's really, if we could paint this, is that if you had a proactive approach to it and you combine this with the data, I think it goes back to the main things, resilience and response. So when you do have an outage, how can we automate that? How can we make it faster? How can we reconfigure? How do we handle the bidirectional flow of energy? I think it's all part of it, is it really comes down to the data, the analytics, and how can we be more predictive, less reactive. I mean, imagine that grid.
Right. Yeah, and it's all about surveillance.
Yeah.
Because that's why, going back to that first question about having the data, it's about as much data as you can pull back and then just start putting together algorithms to figure out. You have very smart people in your companies that can figure out, all right, I'm going to study all the voltages. I'm going to use PMU data to do modeling of the grid to put together the transmission characteristics so that you can compare that to your FERC 715 form filing. You always want to be updating your data because garbage in equals garbage out, right? So the more accurate your model is, the more you can do predictive analysis as it relates to voltage contingency analysis, thermal contingency analysis, and the like. So.
One thing we haven't talked about yet is cybersecurity. What's your perspective of that? That's important, right?
Yeah, yes. It is very important, especially with SIP 6, with PSPs, physical security perimeters, SIP 5, ESPs. You just want to make sure that all the information coming back from a cyber perspective, you got badge readers, you got to make sure your ESP is pristine. You want to make sure that nobody's directly connecting to relays in the back of the panels. We have a tool called Crossbow. You want to make sure there's separation of state and church when you do any of your testing in the substation. Simple stuff is escorting, making sure you have the right folks coming in and out of the station. As you start to penetrate more of the grid and you start expanding the data that's coming back, you just want to make sure that you have that isolation and separation from folks who have access and capability and have the NERC SEP qualifications and certifications to go inside the substation. So that makes a big difference.
Yeah, especially when you have actionable intelligence. If this grid of the future has edge capability to reconfigure, that's a really important factor, because without cybersecurity, you lose some of that, that safety, you lose that confidence, and that's definitely something
The trust, yeah.
Yeah, you have to be able to progress with that. So.
Yeah.
Well, you talk about cybersecurity and expanding data, and now with the increased need for remote work, especially the past couple of years, as you know, how do you ensure privacy and security while implementing data for resiliency and renewables, or reliability in integrating the renewables?
Well, I think, go first on this.
Well, I'll let you.
Yeah. It goes back to, I think, you really have to have sets of standards that are going to evolve with the problem, right? As we become more efficient at predictive analytics, as edge computing, as all of these different wonderful technologies, as AI comes in place, is that you have to have the standards. I know we can appreciate this, because you have to have those evolve with the problem and the solution, and making sure that you still keep that in check while not hindering the ability to go out and have these advanced solutions, right?
Right. And then you have pre-commissioning checklists. You want to make sure that, again, you're checking a box on a host of action items to make sure that you are secure. You want to make sure that you get the information back to the central IT folks so that they can make sure they put them on schedule for patching, make sure you're checking your baselines and everything that goes along with the NERC CIP standards. So it is just critical capturing all that data, all that information, making sure you get it back into a central repository. And then once you go from there, you'll have the adequate surveillance to make sure that you stay within the boundaries and the timeline of when you have to get different actions taken care of on the grid.
Yeah, and when you see capturing data too, it's relevant data that actually has value to it. And
absolutely.
That's a definite part of I think the grid of the future too is, there's a lot of data out there,
Right.
But you have to be able to tell what's valuable data, what was a precondition to a fault, what was, and that high value data, I think, is part of this system as we start to grow it.
Right, but it's also documentation.
Yes.
Because a lot of things take for granted. I mean, everybody has a cell phone, everybody has a camera on their cell phone, so it just makes sense, even when folks go out there to commission equipment, be able to take a quick picture, get the panel information, everything like that, shoot it back, put it in a central repository, so that when things come up and it's like, it's a fire drill and everybody has to go out and go to substations, this would be the great time to utilize that technology. You have cell phones there, capture as much graphical data as you can, get all the numbers. They talk about like barcoding, putting that on all the equipment, whether it be breakers, transformers, what have you. But it's just critical to make sure you're capturing the documentation, a lot of that formal documentation. Some people take it for granted, but when you need it, it's good to have it there, and you can check it remotely from the office as opposed to sending people out when you're trying to deploy a bunch of capital and you have a lot of maintenance you have to take care of. The last thing you want to do is run across the countryside capturing data and taking down information you should have got on the front end.
Thank you. Besides the cybersecurity challenge to the grid, one of the biggest threats to grid resiliency specifically is wildfires, which are becoming more frequent and severe, as we have seen in western states like California, where I'm from, and I've seen some horrible wildfires the past couple of years, especially. So, what are some of the initiatives or innovative ways you've seen utilities manage wildfire mitigation? Dwayne, do you want to take that one first?
Yeah. So with Fact 3, vegetation management, one of the things that first they were looking at 200 kV and above as it relates to tree trimming and veg management. Now that's starting to go down. It's going to go down to 100 kV. So where you had LiDAR, you had folks doing inspections on feet, ATVs, they would go out and drive up and down the countryside, checking the lines and everything like that. But now you have more options using drones. You can go that way. We talked about PMUs.
Yep.
So, you can measure impedance. And then if you see any like encroachment, you can tell a different signature
Yeah,
that
definitely.
would come up?
I think it's operational, definitely, but there's opportunity here too. And some utilities are doing some incredible research and deployment of some systems here that can really detect fire and get that signature prior to, okay, what type of spike, what type of transient is this, and then be able to shut down and isolate this. So there's a data component to this also. Like we were talking about, having branches tapped, there's an impedance signature, there's a harmonic signature to that. So a lot of this data, more operational awareness is going to fall out of it.
Awareness.
Yeah, exactly.
Absolutely.
Because the combination of that with then the vegetation management, and like like you were saying also, the drones, to be able to have the imagery in top of a layer of data, I think really gives us another level of safety, and which is important with the wildfires. And was it the EPSS system that PG&E is deploying? Incredible, right?
Right.
That technology is just going to evolve further and further to the point where maybe it's not as reactive as it is proactive, right? So that data now with advanced sensing, advanced data is now becoming online and becoming more available. So
right. And we talked about satellite imagery where you can go down, take a snapshot, and see whether or not you have any potential encroachments. Deploying weather, making sure, you know what I mean, seeing what parts of the system where there's been a lot more precipitation, heavy growth of trees. You want to prioritize
Predictions, you mean, weather
definitely.
predictions.
Right.
Yeah.
Yeah. So you want to be more predictive. You want to be more prescriptive in where you deploy your resources to figure out what's going on. And then some of the things that we were even looking at is looking at your EMS data, your SCADA data, looking at where you had heavy loads. And then, because then you have the potential for sagging. So you look at where you've been sagging, you look at where you're coming up on your inspections, and if you're kind of later in the game on inspections and the line has been loaded, you can kind of like use that to zero in on which lines to go for first, and so that you don't have a potential tree contact.
So the right digital tools integrated for the use of safety and security is important here.
Yeah, it's a multi-layer approach too. It's operational, it's inspection, it's data, it's situational awareness too. So, and
when you learn from that, that's when you deploy those algorithms, so you don't have to keep, relearning those different things. Because a lot of folks that know that information, in the next 2 to 5 years, they're walking out the door. So then other folks got to relearn that. So the more you can deploy a lot of that institutional knowledge, memorialize it, the better off you'll be moving forward, so that the folks who are coming up behind them don't have to learn the hard way.
Yeah, definitely.
So, Michael, last year Micatu and Zpryme partnered on a report about renewable integration. What are the trends that you're seeing in that area, and what changes or progress have you seen over the past year?
Yeah, that's a great point. Is that the grid disrupted report, when we wrote that last year, is I think we really nailed it when we said that climate change and adverse events are the new norm. And then, the situation happened that we actually had down here in Texas. So that was a big walkaway when I looked back, is the fact that, we have to start thinking outside of the norms. And it goes back to the first question you asked, is that the world is changing, and the way that we have to react and plan for it has to evolve with that also. Some of the progress is exciting as you see the penetration of more renewables. It's the first half of 21. It's another, 20 gigawatts of energy went back out into new renewable sources. So the continued growth is there, and just the acceleration towards this. And I think, one of the things that we've talked about too is that, energy independence is an important thing, right? Both at socio-economical levels, but also at sovereign state level. And it's a priority. And I think we realize is that everyone in this room here is excited to see this happen, more and more renewable energy, but also having a system that's reliable, because we still have to keep the lights on, as we do say, right?
Absolutely. Yeah. Absolutely. Not being at the mercy of different other factions that are out there that you have to tolerate certain issues that are going on in the world today. So the more energy independence that we have, the less likelihood that we'll be at the mercy of anybody else as it relates to their own politics.
I think that's one of the things that when we looked back is that the challenges that we're facing their solutions, but once again, it's going to be an evolution of the solutions too. And a part of the thing we talked about with substations and the age of substations and bringing in electric vehicles and those new loads. You know, I was telling you, I was reading a article, it's like 2.6% of all new car sales are electric. So on the utility side, think about that new load. What's your thoughts?
It's going to be a lot of pressure on the grid for sure,
Right.
because a lot of the distribution systems already built out for the expected load that's out there. So EV and all these other new tools, that's a whole nother level of load that's going to put a lot of stress on the distribution. So it's just a function of how do you balance DG downline compared to what you have sourcing upline, and making sure you have a match between the two.
Yeah.
Right. So my last question is for you, Dwayne, or I want to direct it first for you. Part of improving the electric grid infrastructure is transitioning to a digital grid. What does that mean, and what can utilities do now to prepare for the transition?
Don't panic, for starters. I think, that is a deep question. And I think one of the things that we had talked about before is looking at it in three phases, right? You look at it from the aspect of capacity, our generation resources, converting from coal, oil, and gas over to wind, solar storage, right? So you look at it from that aspect, from a digital standpoint. You're decoupling now your reactive resources off of those generation resources, and you're looking at like StatCons, SVCs, and other digital components that would support your reactive support. And then, just like after the 2003 blackout, you see where they were retiring a lot of generation around Lake Erie, out in the First Energy area, and rather than just getting rid of those assets, they converted them into synchronous condensers. So, I've been in the game for about 27 years, and still having that safety net of a synchronous condenser out there just to have some kind of spinning inertia. I think that helps as a safety net to kind of clean up a lot of where we're converting to overall as a conversion of the grid. So you look at that. You look at substation innovation, where you still have a lot of electrical mechanical relays out there. You want to be able to take into account that you're going to have more computer infrastructure in the control stations, in the substations, video surveillance, everything like that. So as we convert through, and then just your resources, your personnel are going to have to be more digitally savvy. They still have to know the engineering principles. They're still going to have to do relay settings. They're still going to have to be able to do capacitor voltage settings and all that good stuff, transformer tap settings. But they still have to have a digital computer savvy kind of background to be able to handle all the data analytics that are going to be coming their way. So you have more self-sufficiency. You can be able to handle a lot of that in-house, as opposed to always hiring out to handle a lot of that stress. So.
One of the things I see too is that it's more of a customer experience also as we go to a digital grid, is that we have a level of expectation now with the digital world we live in, is having a new level of experience. I think also for the customers is when outages happen, reporting back, more information. And I think the other thing too is that goes back to the EV cars, is when's a good time to charge? How do we set up that infrastructure such that there is going to be more load, and we can't put it all in at once, but that's part of the digital grid, is the usage of it and how people interpret they use it, I think is a big part of it. The other thing too is device level control. And I think that's going to become more and more prevalent, is that, as we put on, energy that's not always production in a linear fashion, and it's intermittent, say the best, is that we have to also consider that that's part of the grid. If we can't store it all, if we can't consume it all, that balance. So there's a level of customer interaction, expectation, and how do we put that together? And it's a challenge, right?
Yeah, and then mobile applications, right?
Exactly.
Because everybody has a smartphone, so then time of day, how do you sync up your phone with your behind the meter to give you those signals? When it'd be the best time to charge your vehicle, run a load of clothes, run a dishwasher, and everything like that. So how do you come up with the logic to come up with a a smart app to let you know like your energy consumption. And of course, you know, you have the AI behind it. It'll study everything that you're doing, but it'll also give you signals based on real-time conditions out on the grid.
Yeah, that's a great point. The digital grid of the future is just not energy consumption. It's going to be a much deeper layer of data from our smartphones, the way we travel, the way we communicate, the way we interact, commute. I think that's all part of it, right? And we're seeing it more and more as big data companies come into the utility space, is that the value of the different data layers, I think, also helps with that problem. It's just not measuring voltage and current anymore. It's measuring your commute. It's measuring, you know, what you do on a Saturday. Because they all know it's part of it.
Right.
So,
and what we do on holidays.
Exactly.
All that other good stuff.
And that goes back to a bigger prediction, and I think AI is a big part of this grid. It has to be.
Great. So we have a few minutes. We have questions coming in for our speakers.
We do. So we will start with it. If we have time, we'll get to more. These are all great questions, so thank you, audience. How do you see the evolution of cyber or physical threats?
Well, go first is that I think they're going to get much more advanced, much more on a tactical level of it's just not going to be the simple hacking and changing. The grid of the future is not only secure, but if you could reconfigure some reclosers, how would that work out? I'd probably not so well.
Yeah, that would be a bad
That'd be a bad
thing.
day, right?
Yeah.
So yeah, the threats I think are going to become more of a challenge because they're going to be at a much deeper level, at an operational level.
Yeah,
So,
they're going to be a lot slicker.
Yeah.
The way that they've been going about it's just not going to be sending you a simple email and clicking on the attachment. A lot of companies have been doing a great job of training their employees as it relates to being more adept to the different phishing techniques that they come across. So I think coming in the front door is not going to be the way that they typically go about it.
Yeah, and I think the approach too is not going to be just at a software level; it'll be at a hardware level, right? Chips and different components. You just got to make sure that's all secure. So
right, and that's SIP 13 from
Yeah,
Yeah, we have time for another one.
All right, well, then I will give you another one. The resiliency is great. Where is the line drawn with cost? When does it become unaffordable for middle to low-income households?
Wow.
yeah.
Yeah.
Well, no, it's definitely a point, right? It's a point that has to be factored in. As cost as anything, it scales as you deploy more, and I think it goes back to the factors of numbers. You know, it's difficult to put solar panels in every house, but it's not difficult for a community to benefit from it. So I think it has to be a little bit more of a perspective of a system versus as an individual component of it. It's all a part of a greater picture, and I think that's an important thing. Is, you know, equality in energy consumption has to be figured into this. I mean, it's a necessity, and energy should be, first off, you know, free of fossil fuels, but second off, accessible to everyone at a fair price. So it's a tough challenge. I mean, I don't think anyone has the silver bullet for that, but it's something
It's
that
a series of programs you got to put together because, again, there are certain areas of town that they still have overhead distribution lines, whereas you got other neighborhoods where you got the distribution line goes down the street and then everything's underground. So I think strategically you just got to go through neighborhood by neighborhood, whether you pick 5, 10, 20%, and just try to reevaluate and rebalance and get it to where all folks can have the opportunity to have reliable power, no matter where you're located.
it needs to be prioritized, right? Well, we got
Yeah,
1 minute.
let's take a quick one.
We're having too much fun.
Yeah, right.
Yeah.
Right before happy hour.
Yeah, we are done with the audience questions. So Hebah, if you had one to end the panel with, that would be wonderful.
I want to thank our speakers. Thank you, Michael, and thank you, Dwayne. Please help me, audience, in giving a round of applause to our
Thank you, guys.
speakers. It's a pleasure talking to you.
Yeah, definitely.